Hello and welcome to Mr. Dakin's maths video on parametric integration. This topic is fairly straightforward, it just comes down to learning a formula. Really. We know from previous videos that the area under the curve can be found by integrating whatever y is equal to with respect to x. By that I mean the area between the curve and the x-axis. The problem comes when y is defined in terms of a parameter. So how could you integrate it with respect to x if y is a bunch of t's? Well, we can use this formula instead. How we got from one formula to the second is by both differentiating with respect to t and integrating with respect to t. These are inverses, so they essentially cancel out. That's why these two formulae are the same. But the benefit of using this formula instead is that we've come up with one which is integrated with respect to t. And if y is given in terms of t, then we'll be able to use that. In order to use this formula, it's just a matter of substitution. Y is cos t. You're going to need to find out what dx dt is. So with this example, the dx dt is sine differentiated, which is cos. So, if you're asked to find the area under this curve, it is the integral of cos t times dx dt, which is cos t again, which we can write as cos squared t, integrated with respect to t. Now, it's just an integration question. To integrate cos squared, or indeed sine squared, you need to use the cos double angle formula. So you need to know that cos 2a is equivalent to 2 cos squared a minus 1. If you're integrating cos squared, you need to make that the subject. So add 1 to both sides and divide by 2. So this is an aside. And now we've found out what cos squared is equal to, we're using t instead of a. So this area is the integral of cos 2t plus 1 over 2. I'm going to factorise out that half to make things slightly easier. And this is integrated with respect to t. So now it's just an integration. Cos integrates to sine. So sine 2t divided by 2. So that's divided by 4. 1 differentiates to just x if it were integrated with respect to x. But it's t, and then divided by 2. Because you'll be looking for an area, these will probably have limits. So you'll now need to integrate between limits of b and a. Whatever the limits are, they need to be t values. Make sure in the question that they are t values. If they're given in terms of coordinates, x and y, you'll need to use the original equations to find out what those t limits are. Again, good idea to practice this from your blue textbook. Page 352 goes through what I've been through here, and then I'll answer some questions after that.